Good evening, everybody. How are you guys doing?
Tired.
Doing okay? All right. I see some of you guys don't have your profile picture yet on the Zoom. Please make sure you have them. Or if you don't have any issue, please turn on your videos. So how the lecture one went on for you guys? Questions from the lecture or the lab? No?
Just thinking of some questions right now, but I think a lot of people on the Discord had problems downloading the what was it? The
Model sim?
mm-hmm.
Yeah. I met Mayuk on my office hour, and I heard that too. So I know Mayuk's problem, that installation didn't go through, or some license issue, something like that. What are the other issues you guys are facing?
I also ran into the issue of for some reason after a while, whenever I tried to click any of the download buttons, nothing happened at all, and then it said something about JavaScript void 0. So I'm not sure how to deal with that.
Oh, I also got the issue to the download form.
Which one? The double space?
So anyone faced that issue and has any solution to that? Yes, Alina? Alina, do you raise your hand? Do you have a question? No, seems like, okay, Alina, yes.
I don't think I raised my hand.
Oh, sorry, my bad. This is my mouse cursor, seems like. Okay, all right. What I'll do, just somebody please drop me an email so that I remember. This weekend, I'll try to install it myself on my system, and I'll record those steps and see if I face a similar problem, then I can suggest you better. Like every year, it can be changed a little bit here and there, their download system. So all you guys are trying from the Intel website, right?
Yeah, I think one of the main issues is that you have to create an account when you want to download it.
Yeah. So yeah, that's so. I think that should be okay. Like
Yeah, it should be fine, but like it asks things like, "What is your company? Like, how many employees are in there?" And I'm just like kind of overwhelmed. Like, I don't sure what to really put in those boxes.
Isn't there a category of student there?
I haven't seen anything
No.
like it.
Yeah, there's no category for student.
I believe those questions are not taken into deep consideration. I just put random things like my company is SJSU, and then I have like 1,000 employees. I just put random information there, and it just lets me get through it.
Yeah, no one
That's
actually. That's okay, I believe, so far.
I registered and still could not download the model sim.
You could not, Ananda?
No, I could not download the model sim.
Okay, so what happens there? Like no link, or link is disabled, or what?
Nothing.
Okay, so it's in the Intel website, right?
Yes.
Okay. Yeah, let me try it myself, and I'll post something for you guys. Let me experience that also.
Okay. Okay. Can we, like, one person can like share the screen and go over the steps, like in the class maybe, if we have time after the class?
Yeah, sure, that can be a good idea also. Yeah, right. I can do, that's what I'm planning to do. I'm planning to record something from my system, but I don't want to mess up with the current installation that I have. I have to do something there. So I'm not I'm not trying to mess up with the system right now. But if anyone else can volunteer, we can definitely go with that idea. Anyone wants to go to the steps, then I can suggest.
Can you repeat that again?
So someone suggested that if we can, like, one of you guys can share your screen and start
I can do it.
process, see what the problem is. So Rahul, you are volunteering for that?
Yep. I mean,
Okay.
I watched the lab. I didn't do any of the downloading. I didn't attempt any of the downloading because I'm doing that in the weekend.
Okay.
But instead of that, I can do the lab live over here and see how that works.
Okay, I just enabled the screen share, so you can go ahead and do that.
Excuse me, Professor, but isn't the lab due tonight at midnight?
Lab due,
No.
that is not graded. It is basically an to-do for you. Like, it's the installation of the whole system, but it's kind of a timeline. So if you can do it by the weekend, that would be great, so that you can proceed with the lab 2 based on that tool.
Got it. Thanks so much.
All right, Rahul, let's try and see what is going on there. Yeah, go to that. Go to that page. Go down. No, not that one. Go down. And go down further. Go down model sim installation from Intel Quadras Prime integration. So yeah, let's start with searching that keyword in the Google, Intel model sim download. Okay. No, that's a picture, so you cannot click it. Yeah, just you need to click on that. Yeah, click on that. Yeah. Okay, click on that download. Yeah, click on that. And now you, no, go up. Select the light. Yep, that should be fine. Then go down more. Hey, where is that model sim? Yeah, model sim. Yeah, go up a little bit. Yeah, model sim Intel FPGA edition. Yeah, download. Just hit on the download button. Okay, here you need to create your, for individual account. All right. There's a good password. Yeah, let's look at there. Where is this? Yeah, put other there. Yeah. Yeah. You can put San Jose State University's number if you don't want to give your personal number. That's okay. No one is going to check. That's a good step. Thank you, Rahul. So what happened, Rahul? Did you were you able to go to the next page? No, you are muted. Rahul, you are muted.
I was just double checking whether or not my number is correct. Because
okay.
I'm still not used to my new number. Okay. So I hit next and we come here. This is the next page that starts.
Okay.
Select, yeah, personal information now, enrollment, project time frame. Say 6 months for 1 semester.
Is there anything, education? Yeah, go to the education.
Education. Are all of these required?
I'm not sure though.
I'm just going to ignore what doesn't
yeah.
need to.
What is it? Yeah.
I believe you
okay.
have to fill them out to go to the next step. So just put in some bogus information and you should be fine.
Preferred distribution, North America.
You can put no preference.
No preference. Company name. Number of employees. Country, region. State. Terms and conditions, and confirming adult 18.
To click on that, I'm not robot.
Before you proceed, please complete the captcha before. Okay. Thank you for first time. A verification email has been sent to you.
So yeah, can you check your email?
I'm checking my email. Can you see YouTube right now?
YouTube.
Wait, what's visible on the screen right now?
Oh, this is your registration first. Thank you for registering the Intel.
Okay, it's still that. All right, fine. So that thing worked. Checking. Still checking.
Okay.
I haven't received it just yet. Resend the email.
Also try spam if you don't see it. Sometimes it goes to the spam.
Checking spam. Got it.
In the spam?
No, it just showed up late.
Okay, all right.
So verify action required. Either you or someone we have request email, login ID. Your password should be present. If you have, you received this message because you're okay. Do not reply to this email.
So you need to click on something there in the email to.
Got it. Found it. It was a very small link. It wasn't quite clear. Thanks. Verified. It's now been verified.
Okay. Now do the same exercise, like click the link, go from there, then log into the account. Yeah, just try the light. Yeah.
Model sim.
Mm-hmm. Yeah. Okay, started probably. No. Yeah, redo that light and download again. I know this interface is not that.
Oh, make sure to do the light first.
Let's see, downloads.
No. You need to again redo that thing. Like yeah, light and go download again. Let's cross our finger that it is now will be downloading.
I tried this like 3 times and it could never work
Yeah.
for me.
It says JavaScript void 0 on the bottom left.
Oh, is that
I
there?
noticed that too.
Okay.
So I'm assuming
Yeah, I
there's a
had the same
JavaScript
issue.
error.
Can you try Firefox or Chrome?
I can do that. Okay, I do have Firefox on.
Let's try it on the Firefox. You're using Edge, right? Microsoft Edge.
No, I was using Brave. It's a Chromium browser.
Okay.
What does it say? More secure encrypted DNS lookups. Okay. Hold on. Stop share and reset to Firefox now.
Okay. Let's hope that works.
Am I logged in over here? I don't think I'm logged in. Sign in.
Wait, mine just worked.
Oh, who's work?
Apparently, I had an ad blocker on, and when I turned it off, it worked.
That makes sense. I have ad blockers on right now.
Because of pop-ups, I see.
That's a good observation. That's a good observation. Huh. See, something new always comes up. We need to put that in the note. Someone please make sure to put that in a discussion, and then I'll just put it on a note or page.
Right.
Professor, which discussion should we put as project 1?
And so now
module 10. Yeah, that's for the Verilog learning, right? Yeah, either way, project 1 or module 10, one of the discussion, just put that in.
Thank you.
Now it is okay. Now it is downloading. All right.
Now it's downloading.
Thank you very much for the idea, whoever given that, to try it now. This is great. John, you did that.
Thank you, John. And now it's just a matter of waiting for 3 minutes.
Yeah.
While we're waiting over here, Professor, I'd like to show you another error that had popped up for me. It's so no, in any module or any page, you have the lecture notes embedded into the page, right, on the Google Drive. Oh, no, has anyone else had this thing come up? Drive.google.com redirected you too many times.
Anyone has a similar problem?
Not
No.
for me.
Not for me.
Try to use incognito window.
We'll give that a shot.
Is it because of which Google account you're logged into?
I thought that was the case, but currently I'm signed into my university profile, which has only one Google account on it.
Yeah.
Yeah, I haven't seen it before, this problem. Yeah, my advice would be, okay, try in another browser. I'm a very layman in terms of softwares, so that would be my solution.
That solution tends to work. I've had a similar problem last semester, and I used that at first, but then eventually it just worked out later on.
Yeah.
And so I didn't have to rely on changing browsers again and again.
Yeah, sometimes these pages, these companies doesn't keep up with the latest and greatest revision of the browsers in the market. They need some time to catch up. That's the whole point. And that's why, like, I don't like to change and upgrade things. Yeah, it may be a sign that I'm getting older, but that is one of the reasons that, okay, whatever is working, okay, let it work. I don't need the latest and greatest browser unless I really need to switch. So yeah, I'm still on Chrome, not even interested in Edge. Microsoft Edge is a newer revision of from Microsoft, right?
Of Internet Explorer 7 or 10.
Right, yeah.
And download is still proceeding, still downloading. 21 seconds left to download.
Okay, let's cross our finger and see.
Yeah. 15, 14, 13, 12, 11, 10, 9, 8.
Okay, now it didn't give you that satisfaction of going all the way to 0 and
nope.
Last off.
It did not do that.
Okay, now let's try it.
Open the file.
Try running it as an administrator, because newer version of these products like Microsoft OS don't like to be run it on the user. So you started that already?
Nope. Firefox hung when I tried to run it. I think I tried to run it before my antivirus could scan it, and that kind of caused a bit of a problem.
Okay, that's true.
And I just got my result from the antivirus. It's safe to down. It's safe to run.
Okay. So maybe you can go to the download folder, right click, and do a run as administrator.
That's the plan. Okay. Yes. So it's running now. Okay. I will share the correct screen now.
All right. Okay. All right. Next.
Next. Starter edition.
Yeah, that's fine.
License is not required for starter edition.
I accept, as if they can proceed without. Yeah.
Wait, it allows you to proceed without accepting?
Don't try that. Yeah, just do an accept.
Installation directory C: Intel. All right, that's fine. Installation directory next. Required space 4000 MB. And it's preparing to install. Wait while setup installs model sim. Oh, Professor Potter, is there any other way to access the Google Drive notes apart from the embedded notes in the page?
You can try clicking. Would be an external link sign. You can try clicking on that.
All right.
And if not, just drop me an email. I'll see what I can do. And I'll start probably putting that external link to the pages as well.
Wait a second. I'll just try loading this, reloading the page without adblock. Okay, it worked. Turned off adblock and the embedded pages worked. The embedded Google Drive worked.
Okay, all right. but that will create some nuisance in your net environment. For other sites, it will just doing that. Oh, you did it for the canvas, right?
I'll do it specifically for Canvas. Block it for Canvas.
Right.
Canvas doesn't have any ads anyway.
Mm-hmm.
I think it does have some tracker from the fact that it uses some Google services, but no ads.
Right. So I hope everyone else is trying this out live. It should work for you guys. Almost there.
Model sim Intel FPGA starter edition installation complete. Setup has finished. Installing that model sim and now finish.
Yep. So now see if there is a link placed on your desktop for the model sim. Try to bring it up.
Okay. Let's see. View, show desktop icons. And Canon. Hold on a second. No link for model sim. So
Right.
I'll just try to do a search.
Right. Or go to that C drive. It went.
Yep, it's here. Found
Okay.
it. 1 second. I'll just share the screen. Screen share. So just the search and start model sim left.
Aha, that one. Yes.
Run as an administrator.
Model sim. Yeah.
All right. Then I'll just open that as a user.
Yep. This is how it starts up.
Dear customer, this is a custom version of Model Sim. It includes our easy to use and powerful user interface and full support behavior for RTL and gate level simulation. For more Model Sim.
Yeah.
Okay. Select Jumpstart to use Model Sim now. Welcome to Model Sim. Create a project or open a project.
You can close it now. It started up. So what you need to do, all need to do is now look for the lab 2 and do those steps. That is the next day's lab. So try that out and see if you can simulate things on your time. But I hope everyone got the steps correct and started installing it. It works for you. Let us know, like put it on the discussion. If you are still having trouble, then someone can jump in and try to see what is going on. Thank you very much, Rahul, for showing us how it worked. Thank you, John, for that idea of ad blocker things. So let's hope it works for everyone else. All right. Okay. What else? What next? What are the other questions for me? Nothing. So let's take 5-minute break at this point. We have a good progress in the class for installation. Let's have 5-minute break, and after that we'll start more discussion. Hello, everyone. Let's get back into our discussion. What shall we do now? Okay, let me try to review some of the understanding on the computing system as we had in our computer systems class, CS47 or equivalent. I hope you all have the similar concept, but taught, but let's review it. Let me share my screen. Okay, so let's start with these memory systems. So if you recall, our computing system does have basic components like memory, controller, ALU, arithmetic logic unit, register files. Remember, like when you programmed using the assembly language, most of the commands went to operate on the register file of the processing system. So let's review them. What is their functionality, what they do. Let's start with the memory. Memory, we can always think of it as an indexed storage, like an array. Like we are all familiar with array in the high-level language, and this array is indexed, and you can access elements with the indexes. The term index that we use in terms of software arrays in memory, the same thing is called an address of the memory. So address is nothing but index in that array. So if you think of our memory as a big chunk of array element of storing values, its indices are our address. That's what we call address. It's just a different term in a hardware world, but it's really an index. Then this is this page where something we can write, something we can read it back, and all this stuff. And that part is done by a memory management unit. And together, this whole system we call a memory. So whenever this is an electronic system, but we are trying to visualize it as some character who is operating on this huge number of elements as in an array. And let's see what it does. It does very simple thing. One thing, we can request this guy to write something, some value at an address. For example, we can request that, hey, write the value 5 in address 3. So what this guy does, this memory management unit, it basically writes that value in the address 3. Similarly, let's say we tell write the value 13 in address 1. So what it does, it go and add, like, write the value 13 in that index 1 in the memory storage. We can do read, like if I do make an instruction request to the memory saying that, hey, read from address 1. At that point, what it will do, it will go and return me 13. It will retrieve the value stored in the address 1 and return it back whoever is requesting that information. So that's one part. Second part is the ALU, arithmetic and logic unit. This is also a simple electronic component in the computing system, which does nothing but, if you ask a mathematical question or an arithmetic question or logical question, like let's say, what is 3 plus 5? It will give you back an answer 8. Later, we'll see how it can do it, how it can compute that addition result and give us back to us. But we'll review that as well. It should be a part of your CS47 study. But if you haven't done so, or that was not covered, we'll cover it very soon and very fast in this course as well. But let's, for timing, somehow let's assume it does return back the correct result of that operation. And then we have the register file, which is practically a glorified memory. Means that it is really fast in operation. It can read 2 addresses at the same time. That kind of advanced things are there, but practically it is a memory, but it is very fast and it is only available limited number like 32 or 64 or 128 number, only that many indices you can find out for the registered file, and you can use them only that limited number. Whereas memory is really vast. It can be like 512 megabyte, 1 gigabyte, and so on. Like many other big memories are available in the market. So these memory space, these can be very big, but register file is very small, limited number, but they're really fast. There's this other component called controller, which is basically the brain and heart of this whole system, which actually orchestrate the operation between these three components, memory, register file, and ALU, to execute the software program you are writing. At a very high level, you are writing a software program, and this guy knows how to execute it. So how does it do? So first of all, this becomes like ALU register file controller becomes your processor, and processor memory together makes your computing system. Just very simplistic model of a computing system. Question so far? No question? Okay, so everybody is on the page, same page. Now let's see. Let's say we have a very high level simple program. Integer A equals 10, B equals 20, C equals A plus B. Very simple, like it's written in C. In Java, it's probably looks similar. In Python, it's a little bit different, but like notion is the same thing. Now, for every variable that you define inside a program, they are nothing but a name for a memory address. So when this program goes through the compilation process or through the interpreter in terms of Python, if you think of in terms of Python, when they go through it, that interpreter or compiler assigns a specific address for each of these variables. For example, let's say in this example, my compiler assigned or says that the variable A is corresponds to address 0. That means whenever program is referring to variable A, we are actually referring to the memory address 0 and its content. Similarly, B refers to 1 and C refers to 2, the address wise. All right. Now, this guy, compiler, breaks this high-level program into smaller and simpler steps like this. I'll explain these steps later in a moment, but it breaks down maybe in a 6 statement. And then there is a tool assembler. Remember this assembly when you did assembly programming in the CS147, this assembler takes this simplified program as a machine code, right? So these are the machine code it generates, and machine codes is the one that your controller understands. So when you start a program, it basically places the machine code into certain location in the memory. It is predefined. Let's assume in this example, it is starting from address 3. From address 3, all this machine code for these instructions are stored. Now there is one more component here. It's called program counter, which works in conjunction with the controller. This program counter or PC's purpose is to point out where the next instruction is in terms of memory address. So let's say when you power up this system, let's say PC starts with 3, a fixed number. So every processor has a fixed value, power up address value. So let's say this example, it's power up at 3. So what it tells that the next instruction to be fetched from the memory address 3, which is here. Now, let's see how it works, how that program is executed. Before I go there, any question for me so far, conception-wise and otherwise? Okay, all right, seems like so far so good. So what does the controller do? It basically picks up this value from the program counter and asks memory to read data from address 3. Program counter returns this machine code. Now this machine code, this controller decodes and understands we want to write value 10 at address 0. What it does, it then instructs back to the memory that, hey, write 10 at address 0, and memory does it. Memory places a value 10 to the address 0. This address 0 corresponds to variable A. Now you see A equal to 10 is executed in my memory. We stored the value there, A equal to 10, reflected on the memory. So now also one thing happened, program counter get increased to the next instruction to be fetched. This cycle happens over and over again. Like controller asks memory to read from address 4, memory returns back that code, machine code, back to the controller. Now controller knows, decode that machine code and knows that, hey, user want to write 20 at address 1. So it instructs memory back, hey, write 20 at 1. Memory writes that value. So now what it does, it practically executed B equal to 20. So 20 value appears on the address corresponds to variable B. Then it repeats read from 5, next instruction, your PC get increased, and read from 5, it gets back the next instruction, and next instruction says that read from 0 and store it on register file 0 address. So accordingly, it asks to read from 0, which MMU returns the 10, that is the value stored there. Now it asks the register file, hey, write 10 to address 0. So it goes and write that address to, write the value to that address 0 of the register file. Similarly, next instruction is fetched. Now that instruction is saying that read from address 1 and store it on RF1. So it sends the instruction to memory, read from address 1. Memory sends back 20. It asks register file to write 20 at address 1. Register file over that, put the 20 in the register 1. Then fetch the next one. This guy is telling controller that, hey, access register file 0 address, access register file 1 address, add them up, and store the result back in register file 2. So at this point, what it does, it asks register file to read from 0 and 1. So that's the one difference from register file with the memory. Memory can read one address at a time, whereas register in this model, register file can access 2 address at one time, at single time, and send back 2 results to the controller together. Okay, so it returns back 10 and 20 to the controller. Then controller sends that addition query because it's addition operation. He said, hey, ALU, what is 10 plus 20? ALU returns back, okay, it's 30. Then controller takes that value 30 and asks register file that, hey, write 30 to address 2. So it write that 30 to address 2. And PC increase to the next instruction address. So next cycle, it reads from address 8, fetch the instruction. Now that instruction said, hey, read from register file 2 and store it at address 2. So it asks register file to read from address 2, register file return 30, then it asks memory to write 30 at address 2, and memory writes it. Now you see this address 2 corresponds to variable C, and now variable C has a value 30. That's what your high-level program trying to do, isn't it? So see, like we kind of took like almost like 10-15 minutes to describe the simple program and steps, what is being done inside our computing system to execute a high-level program, but it is really, really fast. like in order of nanosecond. So if you recall, the nanosecond unit is 10 to the power minus 9 second. So it is that fast, modern processor. So it doesn't seems like it will take a longer time, even it executes so many steps. It can just execute this 3 line within probably microsecond range, or maybe less than that. All right. Question. Now, if you recall your assembly programming skill, like your assembly programming doesn't look like that, it something looks like this. Similar, like if you are familiar with MIPS assembly, it's very much look alike, you know that already. If you are familiar with x86 or other processor like ARM, it is similar, not the same, but it's similar, and each processor supports a specific language set. And each language has its own construct and own semantic meanings that what it's trying to do. But it boils down to the similar program like that, isn't it? Does it look familiar to you guys from your CS147 experience, right? Okay, so this is how things are executed inside a processor, and we will stay with this whole concept entire semester, and we'll do project on this concept. We'll do our exercise with this concept, and our target is to make things faster. As we go beyond midterm, we'll start doing that. We'll start seeing how this processor can be made faster with some steps, some conceptual step like pipelining, parallel execution, all this stuff. But we'll start with this very, very simple concept, and we'll start put together a real hardware system in a simulation environment that does exactly this step together. All right. Question.
I have a question.
Yes.
I'm just wondering if you'll be reviewing things on the way that we need to know, like in class meetings, or if we'll have to check on like the modules and like the old lectures, like from modules 1 to 4, because he said those were review, right?
Yes, those are all these lecture videos. So I kind of expect that you guys review that before coming to the class. And if concepts are not clear, then you start asking questions around that topic.
Okay, but when I check Canvas, it says modules 2 to 4 are locked, and I have to finish like the previous module.
Right. So you need to go through sequentially those lectures 1, 2, 3, and once you click on that, you should be able to jump to then module 2 will be unlocked for you.
Okay. All right. Yeah. Thank you.
Okay.
So, but when it comes time for like if we have questions on that, that's when we would bring it to the class meeting so that we would actually like ask those questions that we have.
Right. And also I would encourage you to actually put your question up front on the discussion, so that if it is a very simple or someone else can jump in to answer your question, that would be great, some other student. Or if I have time, I'll explain that like immediately almost, or I'll discuss them in the class if I haven't answered that already on the discussion.
Okay, thank you.
Yeah, in that regard, like I'll encourage everyone, like if you see some question posted on some discussion, see if you know the answer. If you want to, you can participate in some discussion in a way, please do so. Like you might have the similar questions, so you can say that, hey, I have similar question. That's what I kind of predict this is going to be like these, and so on and so forth. So please do start some active discussion in the class. All right, that's the only way we can learn together. Right, it's not an individual effort anymore. All right, this is a complex subject, so you guys need to help each other. All right. Okay, now let's see what is coming up next day. So again, we'll go to the syllabus. Let's see. And let's see. 30, so 29, right? 29, we have two things. One is lecture 2. So here we'll talk deeper details into the subsystem, especially we're done with the ALU in the lecture 1. So clock system model, that's what you need to understand very carefully, why we need a clock system and how it affects and how it relates itself to the synchronization of the whole subsystem, like controller synchronization with the memory, synchronizing with the register file, synchronizing with the ALU. So clock system plays very vital role in the modern computing system, and you need to understand that concept very well. Like, what is the physical meaning of a clock? What is the electronic meaning of a clock, and so on and so forth. Then we dive down into the memory system model. I just described today a very simple way what memory does, but we'll discuss in deeper detail with respect to the clocks, like what happens, what event happens when, and how that raises into some certain constraint of operation. You cannot do every operation back to back with the memory and so on and so forth. So we need to understand and pick up that complex concept. And for that, you need to have a very clear understanding of the clock system model. So please pay attention to that. Then we talk about the control unit model. It's kind of a 5-stage model that we'll follow throughout this semester. We'll develop processor, which is a 5-stage processor. We'll test on that. So please pay attention to that as well. After that, we'll talk some about the theoretical architectural aspect of two architectures, especially von Neumann architecture and Harvard architecture. Both are applicable even in all modern computing systems. Both of them are equally valuable, equally applicable to all computing systems that even you are using right now. Then we touch base a little bit on the software system softwares like compiler, assembler, linker, loader, little bit on operating systems, and try to understand what is the link between the hardware and the software world. To me, conceptually, operating system study and this computer architecture study should go hand in hand. Like, you should plan to take either both together. I know both together are really two heavy courses, but they really go interlocked together. Okay, computing system and architecture and operating system. If not, I would always suggest you either you take architecture, immediate next semester take operating system, or vice versa. You take operating system, immediate next semester take computer architecture. Then you can start relate, like how the operating system is affecting computer architecture and how computer architecture is affecting operating system. They're basically interlocked and interdependent subject together. So please keep that in mind. And if you have done operating system long back, I would say please just quick review, brush up your memory on the operating system. All right. Okay, so it has quite a lot of videos to observe here, 5. Please make sure you schedule your time accordingly, watch it, and we'll go from there. Okay, then we have our lab for the next day, which is hierarchical modeling. So we'll talk about like how we can start describing hardware component in terms of a language, like the Verilog language. We see some code. And don't worry if you don't know what is DFF, inverter, never mind. Like, it's just pick up the concept, like how to use the model sim, how to simulate, how to observe the clock diagrams and waveforms to understand the components behavior. So that's all our target is for this model, lab 2. Okay, so make sure you download the code, go through the concept, go through some little structure about that, about those Verilog structures. And main purpose is to like practice how do you compile, how do you simulate on the environment, how do you look at the waveform structure, waveforms on the visualized on the models in GUI to understand these hardware systems behavior. So please get familiar with this whole concept that is being described in the lab 2. All right. Okay, I think that's all for tonight. If you don't have any other question, we can wrap up early tonight. Let me see if we have any question from anyone.
Yeah, I have one question.
Yes,
so lab 2 that's going to be done on model sim, right?
Yes.
Are we going to have like a tutorial on how to actually maneuver around model sim, or?
I believe, yes, that video has that.
Oh,
So,
okay.
Yeah. I believe.
Thank you.
I'll check the video once again tonight and see, make sure if it's there.
Okay, thank you.
Other questions?
I just want to make sure that all the class recordings are available on the cloud recording area, right, in Zoom?
Class recording, the recording being made here during the class?
No, I was asking like, where can I view the recording? Like,
or lecture recording, you mean?
Yes.
Oh, you go to the pages, right? You go to the, let's say, syllabus, or even you can go through the module. Let me, sorry, I'm not sharing the screen, just hold on. So you can click on the module also. Let's say lecture 1, right? So you go to click on the lecture 1, and then first part is the lecture note, and second part is the videos. You can click on the play and watch that.
Oh, okay, that's great. But I was talking about like this recording right now where Rahul did the demonstration and everything.
Yeah, right. So basically for the lab pages as well, lab page also has a video link and a note link. So you need to visit those pages. Okay, and for the I think you can click on the Zoom for the recording. As I make it available as soon as it is up from the system, and also you can go to this page for this class recording. For example, you go to this link, online class recording. This page has like link to the YouTube videos that is being
that's perfect
right now. Yeah.
Okay, that's perfect. Thank you.
Okay. All right. Other question? All right. Let's stop tonight and see you on today's what? Wednesday, next Monday, right? Have a good weekend.
Oh, hi, Professor.
Thank you. Bye-bye.